Hi, this is Joe from the Math Perimeter, where I help to make mathematics accessible, engaging, and approachable through various forms of content. In this video, you will learn how to differentiate functions using logarithmic differentiation. For more information about this topic, please refer to the article linked in the description. In this video, we will use logarithmic differentiation to differentiate the functions y equals x to the x and y equals x squared plus 6x plus 10 times the natural log of x all over e to the x times arctangent of x. The first function we will differentiate is the function y equals x to the x. To begin, we take the natural logarithm of both sides to arrive at ln y equals ln of x to the x. We now rewrite the right-hand side using logarithmic properties to get ln y equals x ln x. We are now ready to implicitly differentiate this. To begin, we take the derivative of both sides, which gives d by dx of ln y equals d by dx of x ln x. To differentiate the function on the right-hand side, we apply the product rule, which gives us d by dx of ln y equals ln x times d by dx of x plus x d by dx of ln x. To differentiate the function on the left-hand side, we apply the chain rule as well as the formula for the derivative of the natural logarithm. Doing this, we find that the derivative is 1 by y dy by dx. To differentiate the first function on the right-hand side, we apply the power rule, noting that x has an implied exponent of 1. Applying the power rule gives 1. And to differentiate the last function on the right-hand side, we apply the formula for the derivative of the natural logarithm, which gives 1 by x. Putting all this together, we obtain 1 over y times dy by dx equals ln x times 1 plus x times 1 over x. Simplifying this equation gives 1 over y times dy by dx equals ln of x plus 1. We now want to solve for dy by dx. To do this, we simply multiply both sides by y to get dy by dx equals y times ln of x plus 1. We now substitute in for y to arrive at a final answer of dy by dx equals x to the x times ln of x plus 1. Next, we use logarithmic differentiation to find the derivative of y equals x squared plus 6x plus 10 times the natural logarithm of x all over e to the x times arctangent of x. We begin by taking the natural logarithm of both sides, which gives ln y equals ln of x squared plus 6x plus 10 times ln of x all over e to the x times arctangent of x. We can now rewrite the right-hand side using logarithmic identities. This gives us ln y equals ln of x squared plus 6x plus 10 times ln of x minus ln of e to the x times arctangent of x. Expanding the two logarithms on the right-hand side now gives us ln of y equals ln of x squared plus 6x plus 10 plus ln of ln x minus ln of e to the x plus ln of arctangent of x. We now evaluate ln of e to the x, giving us ln of y equals ln of x squared plus 6x plus 10 plus ln of x minus x plus ln of arctangent of x. We now distribute the minus sign, giving us ln y equals ln of x squared plus 6x plus 10 plus ln of ln x minus x minus ln of arctangent of x. We now differentiate both sides of the equation to obtain ln of y prime equals ln of x squared plus 6x plus 10 plus ln of x minus x minus ln of arctangent of x prime. To differentiate the right-hand side, we use the sum rule, which gives ln of y prime equals ln of x squared plus 6x plus 10 prime plus ln of x prime minus x prime minus ln of arctangent of x prime. To differentiate x, we use the power rule, noting that x has an implied exponent of 1. To differentiate the natural logarithms, we use the chain rule along with the formula for the derivative of the natural logarithm. This gives us y prime over y equals x squared plus 6x plus 10 prime all over x squared plus 6x plus 10 plus natural logarithm of x prime over ln x minus x prime minus arctangent of x prime all over arctangent of x. To differentiate the numerator in the first function on the right-hand side, we apply the sum rule. This gives us y prime over y equals x squared prime plus 6x prime plus 10 prime all over x squared plus 6x plus 10 plus ln of x prime all over ln of x minus x prime minus arctangent of x prime all over arctangent of x. We now apply the constant multiple rule to the 6x prime term in the numerator of the first function on the right-hand side. This gives us y prime over y equals x squared prime plus 6x prime plus 10 prime all over x squared plus 6x plus 10 plus ln of x prime all over ln of x minus x prime minus arctangent of x prime all over arctangent of x. We now differentiate the various functions using the relevant rules and formulas. This gives us y prime over y equals 2x plus 6 all over x squared plus 6x plus 10 plus 1 over x all over ln of x minus 1 minus 1 over x squared plus 1 all over arctangent of x. To simplify the expression on the right-hand side, we multiply the second term by x over x, and we multiply the fourth term by x squared plus 1 all over x squared plus 1. Doing this, we obtain y prime over y equals 2x plus 6 all over x squared plus 6x plus 10 plus 1 over x ln of x minus 1 minus 1 over x squared plus 1 times arctangent of x. Multiplying both sides of the equation by y gives y prime equals y times 2x plus 6 all over x squared plus 6x plus 10 plus 1 over x ln of x minus 1 minus 1 over x squared plus 1 times arctangent of x. Substituting in for y gives us a final answer of y prime equals x squared plus 6x plus 10 times ln of x all over e of x arctangent of x times 2x plus 6 all over x squared plus 6x plus 10 plus 1 over x ln of x minus 1 minus 1 all over x squared plus 1 times arctangent of x. Thank you for watching. I hope you enjoyed the video. Please like and subscribe. Thank you. See you next time.